This is the second in a series of videos on confidence interval for population proportions. And where we ended the last video is we were looking at p hat, which is an estimate for p, the population parameter. So this is the sample proportion. And this is the population, or true proportion. And what we looked at is, under certain conditions, the estimator, p hat, first is unbiased. That is, mu p hat is equal to p. The second is that it is normally distributed. And the third is that sigma p hat is equal to the square root of p times 1 minus p. And the question is that if this is true under certain conditions, what are those conditions? And the conditions are that those are random. That is that the sample that you drew is random, that they're independent draws, that is, any given observation is independent from every other observation, and the next is that the sample size is large enough. And we'll go over the details of what large enough means later. The next thing we do is we want to talk about the standard error of a statistic. And here's the key. The key is the standard deviation of a statistic is often unknown. So the standard error of a statistic is the estimate of the standard deviation of a statistic is called the standard error. So the basic idea is this, but when we've done problems before, we've always assumed that we knew what the standard deviation was. So, but in fact, we don't often know that, so we have to estimate it. We estimate it from the sample. So whenever we use the sample to estimate the standard deviation of a statistic, we got the standard error. So here's an example. If you're estimating p with p hat, then we know that what's going to be true is sigma p hat will equal to the square root of p times 1 minus p. But the problem with that is that we don't actually know p oftentimes, right? So if we have to estimate p with p hat, then we get this. We get sigma p hat times 1 minus p hat over n. Now, we could use the notation like this, sigma p hat, hat. But that's a kind of clumsy notation, so we simply call this number right here the standard error of p hat. So again, what we're doing is we're going to estimate sigma p hat. We know that sigma p hat is equal to the square root of p times 1 minus p, but p is unknown. So we use p hat to estimate p, and then we know that we can estimate sigma p hat then p hat times 1 minus p hat over n. And that's called the standard error. Of p hat. And though we're talking about p hats now, this concept of standard error is going to be used in all of our problems. So that's the end of the second video, and in a second we'll start on the third video.